Hey everyone, this is Big Face from Big Face Robotics, still working on the Robot Head Mark II. We left off the last video with some detection working for templates of objects in the environment, and I've now moved on to tracking those objects, or certainly trying to centre them in the camera's view. To start this, I was just using proportional control, working out an error in the X and Y camera coordinates, and using that to drive the servo pan and tilt positions to try and centre the object in the field of view. So this worked to some degree, and the object would be almost centred in the camera's field of view, but the resolution of movement wasn't good enough for the object to be centred every time. And if you have a look at some of these clips, you can see that working, and you'll see that occasionally the robot will stop and the object isn't fully centered. So to improve on this, I went to PID control. So two loops running, one for the X direction and one for the Y, or pan tilt, depending on whether you're using camera coordinates or the robot pan tilt positions. So after a bit of tuning, this was much better than just using proportional control on its own. And again, you'll see from some of these clips that the object is being centered in the frame much more accurately. There is a bit of overshoot at times, but that's quite small, and again the tuning took care of that. And after a second or two, the object is centered in the frame and is steady. Since the last video, I've rewritten a lot of the Python code as well. It was starting to get a bit messy, so I've taken things out and put them in their own classes. And one improvement was making a class for information about each of the features. This holds things like the feature name, the type, the pan tilt location, the XYZ coordinates of the feature, and the rules for updating the feature's position or any other information about it. This tidies the whole thing up and makes it much easier to manage. I'm also looking after the list of features, if you like, by putting the class instances into an array, and then I can deal with all of the features at one and cycle through them and work with it like that, and that's working quite nicely. So if we move over and look at the software running at the moment, it will look quite familiar with the pan tilt controller in the corner here and the raw data coming from the robot, the OpenCV window and the robot model. And I've got a list down here of features that I've already selected and added to the list. And if you remember from the last video, if I select detect on an object, it will pick out that object in the scene. So I've got one of the house symbol, there's the camera, and there's the distribution board, but no tracking's happening at the moment. It's just detecting these in the camera's image. If I now hit track, you'll see the box turn green because that image or feature is now centered in the robot's field of view. And as I cycle through these, the robot head will move to where it thinks the location of these features are, and it will then center the camera, or center the feature in the camera image using the PID control. I said about the class holding some information about the feature. One of those, if you look down here, is the pan tilt position, or where the robot needs to be to roughly have this feature centered in its field of view. And as I cycle through them, the robot will automatically move to the last known position of that feature, and then the PID loop takes over from there, and we'll do the final centralization of that feature in the robot's field of view. I've got one right over the other side of the room. Some plug sockets, and there we go. So all I've got to do is click one of these features in this box, and the robot will move to look at it, which I think is quite nice. As you can see, this is a live demo, so if I manually move the robot, it will bring itself back to centralise the feature in its field of view from all directions. as I said, a small amount of overshoot, and then it settles down very quickly. So it's quite a nicely tuned PID loop. If you look over at the robot model, you'll see the model of the robot itself with these red lines and the green line representing the sonar reading. And you'll see the red dots on this image, or on this model, are showing the approximate positions of the features in 3D space. Now the distance to the feature is calculated using the pan tilt positions of the robot and the distance measurement from the sonar sensor. And as you can see, the positions in the model are occasionally being updated. I've got a rule that says if the error is small, it'll allow the position to be updated. If the error is large, it doesn't update because there's potentially an issue with the sonar reading or something else, or the robot's moved significantly and it won't update the feature positions. And that leads me on to a slight issue with the way I'm doing things at the moment, and that is the inaccuracy of the sonar sensor. It's well known that these have a wide beam angle and are okay for detecting distances up close or in plenty of free space, but what I found from my testing is that if the robot's looking at an object a long way away, anything else in the environment nearby, be it something else on the table with the robot or me sat nearby or anything really, will really affect the sonar reading and the accuracy. So the 3D model isn't particularly accurate and isn't providing much more information than just the pan tilt values alone. So that was a bit of the motivation for making this video, because I'm going to have a bit of a rewrite of the code and probably do away with the use of the sonar and the 3D model at this stage, and just map the position of the features in pan tilt space, and that should give me enough to map the robot's environment, because it doesn't move around. It really only needs to know roughly where it needs to turn its head to see these features again, and that might be a nicer map and an easier one to work with. So it'll be a shame to lose the 3D model, because it does look quite cool and has been an interesting learning experience. But for now I'm going to simplify this a little bit and go with just a 2D map of the robot's world. And then I'm going to start introducing some other features for it to detect, be it a ball or a symbol or something else that allows people to interact with the robot, because I want to try and make this thing seem a bit more alive, a bit more interactive, and have a bit of fun with it. So thanks for watching, and I'll be back soon.